So for this one, if we look at example 1a, we have x squared plus 10x plus, we're figuring out what value there would make this a perfect square. So what we're going to take is the value for b, which is the number in front of x. So we're going to take 10, divide that by 2, and then square that number. So 10 divided by 2 is 5. 5 squared is 25, and so 25 would be the value that we would use to make that a perfect square. So then for b, we have negative 14 is the value in front of x. So if I take negative 14, divide it by 2 and square it, I get negative 7 squared, which is positive 49. Do you guys remember this? Yes? Okay. So then what we're going to build into tomorrow is stuff that looks more like C, where notice the difference between the first term for A and B, it was just x squared. For C, there's a number in front. And so what we want to do first is factor out that number and then kind of look at it from that standpoint. So if I factor out the 2 from what I have, I think about this as x squared plus that becomes 6x plus something. Now I'm looking at b as being 6 instead of being 12. So if I do 6 divided by 2 and square that, that gives me 9, but 9 isn't my answer because that's inside the parentheses. Notice that we factored out a 2, right? So what I have to do to figure out what it is here is think about if I were to distribute this back, what number would be in the blank? Good, 18. And so the value that makes that into a perfect square is 18 for this one. So today we're going to work with all the kind of different forms of parabolas in different ways. To start with, we're going to be taking something in standard form and write it into vertex form. And then we'll also use factored form and write that into vertex form. So just to remind you of each of the different forms and what they each show us. Remember that the value for A is the value that tells you how like wide or narrow or whether the parabola goes up or down. That's the same for every form. So if A is 2 in one form, it's 2 in all 3. In vertex form, remember the value inside the parentheses, we change the sign when we identify the vertex. That's the x coordinate h, and then k is the y coordinate. The line x equals h through that vertex is called the axis of symmetry. And then standard form is where it's not factored or anything. So ax squared plus bx plus c, that tells us the y-intercept, and the y-intercept value is that c. And then factored form is a times the quantity x minus root 1 times x minus root 2, where roots 1 and 2 are the zeros of the equation, so the x-intercepts. So we're going to start with given something in standard form and write it in vertex form. So we're going to use that strategy that we used in example 1 to complete the square. Can I move it so you can't see the formulas anymore? Yeah. Okay, so we're doing this using kind of a 3-step process. The first step is that we're going to add and subtract that value, okay? So now we have an equation, so we have to keep the balance. We were just talking about what number it was in the last one, and we just wrote it once because we were talking about what would make it a perfect square. Now we're going to do that, but we also don't want to change the graph of the parabola. So whatever we add, we have to also subtract. So it's going to look a little funky in that regard. So what we're looking at is taking our equation of our line. So we've got y equals x squared minus 12x, and we're going to complete the square. But then we still have this 40. And to keep the balance, we're going to subtract whatever value we add. Okay? So those two blanks are going to add to 0 because we're adding one, subtracting the other. But to figure out what we're adding and subtracting, we're doing what we did in example 1, which is we're going to take this negative 12 this time. So that gives us negative 6 squared. So we're going to put 36 as each of those blanks. So if I was to combine like terms, I would still have the original problem. Okay, so that's really the same thing as what we just did in the previous example, except we're also subtracting because we have a whole original expression that we want to keep the same. So then what we're going to do is we're going to factor this perfect square that we made. So the perfect square we made is these terms. So what we want to be able to write it as is as a perfect square. Okay, so our big idea here is to have this in vertex form. And so we want to figure out what this perfect square is that we just created by completing the square. And so remember that to do this, we can just think about a product sum chart, or if you prefer to draw out magic X. We're looking at what numbers multiply to that 36 that we found and add to the negative 12 that we used. And so it's 6 and 6, and they're both negative, right? And so that means that we're going to take negative 6 and negative 6, which means that as a factor, this is x minus 6 squared. Wow, I wrote that really funky. Let me fix it. Okay, so the factored form of x squared plus minus 12x plus 36 is x minus 6 squared. Are we okay with that? Yeah. We will do, yes, so you're correct, but that's when we identify the vertex. So when I'm writing the equation, the factors, it has to be negative 6 and negative 6 to multiply to positive and add to negative 12, right? So when we say the vertex, yeah, we're going to say it's positive 6, not negative. So you're right there. And then what we have to do, the last step, is to combine the like terms that we haven't touched yet, and that's going to give us our value for k. So if I combine 40 minus 36, what do I have? So it's just going to be a plus 4 there at the end. Okay, so what we just created is the vertex form. Of the standard form we are given. So our vertex form is y equals x minus 6 squared plus 4. They want us to identify the vertex and the axis of symmetry. And I'm just writing AOS. Okay, so what we just talked about is that when we identify the h value for the vertex, we take the opposite of the value inside the parentheses. So since we have a negative 6, that means that the vertex is at positive 6 for the x coordinate. And then it's at positive 4 for the y coordinate. So this, the first one's always the opposite. Okay, so vertex form, and then the vertex and the axis of symmetry. Are you ready to flip? Okay, so we're following through with that same process. We need to find the value of b squared, sorry, b over 2 squared, Then we need a factor, and then we're going to combine like terms, okay? And so let's kind of spread out our expression so that we have, sorry, our equation, so that we have room to complete the square. So remember, we put a blank adding before the C value, and then a blank subtracting after. And the first three are going to make our perfect square. The last two are going to give us our K value. Okay, so B in this problem is what number? 2, so we're going to add 1. Good. So if I divide 2 by 2, I get 1. 1 squared gives us 1. So we're going to add and subtract 1. Remember that we're factoring those first 3 terms, that first trinomial, so we want 2 numbers that add to the one that we just got. Sorry, multiply to the one that we just got and add to 2. And so that one's easy, 1. So it's 1 and 1. So that means that our factored form is going to be x plus 1 squared. And then 5 minus 1 is going to give us 4 again, so then plus 4. We don't have very much variety in our values for K. So that's the vertex form of our equation. What's our vertex then? Good. So our vertex is -1, 4. And our axis of symmetry is x equals that -1 value. So our answers are the equation, the vertex, and then the axis of symmetry. Okay, so that was us given standard form, and writing vertex form, we had to use completing the square. For example, 3 were given factored form, and they want vertex form again. So the process is a little bit different because we don't have a set procedure. I mean, we could multiply out the 2 factors and then do that again, but that's a little slower than just having something else that we can do. So if I have factored form, in this case, x plus 2 times x plus 4, that means that my values for the roots are actually the opposite of the numbers that I see. So since the first number here is plus 2, that means that a root is at -2. And then since this one's at +4, that means that the root's at -4 plus 2. So that rule about, in parentheses, opposite sign still holds, okay? So same that it did with K, sorry, H, because of the setup of the original equation. So to find, bless you, the value for H, we're actually going to find the average of those 2 values because the vertex is perfectly in the middle of the x-intercepts of the graph. So we're going to take and add those 2 numbers together and divide by 2. So if we take -2 plus -4, that gives us -6. Divided by 2 tells us that H is -3. Okay, so if we think about the idea here, then we know y equals, A was 1 here, so this is still a 1. And then it's always x minus h squared, so that's going to be x plus 3 squared. What we need to find next is what is the value for k. And to do that, we're actually just going to plug -3 into the original equation. Okay, so we're going to plug into the y equals x plus 2 times x plus 4. So k is going to be equal to we're going to plug -3 in for x into x plus 2 times x plus 4. So we have -3 plus 2 in parentheses. That means we technically have -1. And then we're multiplying it times -3 plus 4, so +1. So that means that k is -1. Bless you. Okay, so our h was -3, our k is -1, so that means our vertex is, that h is our x, k is our y. Bless you. And then our axis of symmetry is x equals that -3. Okay, so we found the two x-intercepts by changing the sign. So we had +2, that meant it was -2. +4 meant it was -4. We added those two numbers and divided by 2. That's the h value. Then we had to plug h into the equation to get k. And this lesson seems jumpy because we kind of have 3 different things going on, right? So we had completing the square in the first 2 examples, and then this one was totally different, and then the next one's totally different because we're just practicing graphing. So when we graph parabolas in vertex form is the easiest way because we can follow patterns. So what I have written up here is 2 different patterns. So it kind of depends on what your teacher showed you in Math 2, and we did these both ways again during first semester. But there's essentially 2 different ideas, and you either start from the vertex and go back to the vertex each time you find the next pattern, or you build from the point you just graphed. And so I'll go through each of them. So don't necessarily write this down until we go through it because you only really need one of them. So you shouldn't have to know both methods. So the first thing that we want to do for either method is figure out the vertex of the graph, which is what for this problem? 1, 2. Okay, so our h value is 1 and our k value is 2. So we're going to plot the point 1, 2. In this problem, a is -2, so we're going to have to multiply our pattern by -2 to figure out which way we're going and how far. So there's 2 patterns again. The first pattern, you're using the vertex every time, and that's using the perfect square idea. So if I go out 1, what's 1 squared? 1, so I would go up 1, but since I have an a, I have to go up 1 times a. Then I would go back to the vertex and go out 2, and then 2 squared is 4, so I would go up 4, but since I have an a, I would have to multiply 4 times a. So if that's the method that you learn, if you want to write it down or just use it, that's which one you should do. The other method is using odd numbers and just building. So the first one's the same, right? I go out 1, up 1 times a. Then from the next point, I would go, actually I'm going down because it's negative. So then I would go out 1 and down 3 times -2, right? So depending on which method you were using, we're either going out 1 and then down 2. Oops. And then back to the vertex, out 2, down 8. Or you're going out 1, down 2. And then from that point, you're going out 1, down 6. Okay, so no matter what, your first 2 points are going to be here. And then if I'm going down 6 if I'm thinking about it that way, 2, 4. I'm gonna be here. Or from the vertex, I'm going out 2, down 8. I'll still be there. Okay, so no matter which pattern you use, you should end up with those 3 points to draw that parabola. I lost the T somehow when I copied and pasted. Okay, so since A was -2, it's pointing down, and it's kind of narrow, right? So the value 2 made it narrow, the negative made it point down. If I have a positive 1/2 for my A for the next one, it's gonna be pointing up and be more wide, okay? So that fraction is gonna make it look a lot wider than that graph. So for this one, we have 1/2 times x plus 3 squared plus 1. And so our h value is what for this one? So our vertex is going to be at -3, and then the y coordinate is 1. Okay, so if we go -3, 1. Okay, so from there, since A is 1/2, we're going out 1 and then up 1/2. So that means that we're gonna go here and here. And then depending on our method, if we go back to the vertex, that means we're gonna go out 2, and 1/2 of 4 is 2. So we're gonna go up 2, so we'd be there. Or if we're using the other method, we're building, and 1/2 of 3 is 1.5. So we'd be going out 1 and then up 1.5 from those points. Which gives us that wider parabola. Okay, so the problems for the assignment are just written below these examples. So you have 2 questions that are like example 2, 2 questions like example 3, and then 4 graphs, just so you can kind of get a little bit of everything. Bless you. And I'll put out graph paper, so if you want to use some, if you don't have a graph paper notebook.